I think it is the maximum volume, I guess. It was same from my side. That's fine. You are audible.
Yeah, right, good. So yesterday we started a demo session where just I have given introduction to data structures and algorithms course. It is 5 weekends batch. The timings of this session is from 7 to 9:30 p.m. Fees is 3,000. It is a 5 weekends batch, excluding today. Okay. And what syllabus we are going to cover, I explained very clearly. If any new person is there, so you can watch yesterday's class video is uploaded in our DurgaSoft YouTube channel. You can go through that. Okay. Next, coming to the yesterday's session. So we have started recursion means what? What are the various recursive algorithms are there? So to demonstrate this recursion, how the control is moving from main method to another methods, if any methods are available, we have seen. I mean, the transferring of function calls from one method to another method. So while doing this, JVM is going to create one empty stack at very beginning, and it will store all this information like a method calls, everything. So inside that stack, each entry in the stack is called as stack frame or activation record, and when which function called which function, and when these functions have to execute, everything will be available in that stack. So in the last class we have taken one simple example, even with multiple methods, how that stack is going to work I demonstrated, and we have given introduction to the recursion also. So what is recursion? Generally a method which is called by same method. A method which is called by same method is called as a recursive method. Okay. And this process, whatever we are doing, is called as recursion. If you take any Java program, like yesterday, we discussed about this. If you take any Java program, so you can see this is a recursion, right? Because the program execution starts from main. In the main, we have one method call. Immediately, the control is moving from the 10th line to third line because the definition of this method is available here, and it will start executing. It has two instruction. What is the first instruction? It will print hello. After that, we are calling the same method again. Again, it will print hello. We are calling the same method. Again, it is going to print hello. We are going to call the same method. So there is a never ending process. This process is called as what? Recursion. Continuously. So it is a keep on executing. If you want, you can see the output what we are going to get like this. Java C test.java Java space test. You can see continuously it is printing. But at a certain point, we are going to get one overflow error because I told internally it will maintain one stack. So whenever that stack got full, automatically what will happen? We are going to get a stack overflow error because for JVM, certain amount of stack space is given at the time of installing Java. Okay, it varies from server to server and mission to mission. Sir, how you can able to stop? How you can able to stop? For that, we have to go for which one? Base conditions. So before that, case one. What is a case one is based on based on based on number of method calls. So we have two types two types of recursions are available. Two types of recursions. What is the first one? The first one is called as infinite. Okay, infinite recursion. So second one is nothing but what? Finite recursion. Infinite recursion means what? Keep on, it is going to work. It will never stop. The example whatever we have discussed now is infinite recursion. At a certain point it is going to stop. What is that certain point? Stack overflow. But if you want to stop manually, it is not possible. Such a type of recursions are called as what? Infinite recursions. Okay, which will never stop. Sir, I want to stop. Then what we have to do? You need to put some base condition. So what is mean by base condition? It's a very simple, sir. To terminate, okay, to terminate or to stop recursive process. recursive process. So we have to supply explicit condition while defining the method. So this condition is called as base condition, sir, which is very, very important, sir. Okay. So more priority we have to give for this base condition, because if there is no base condition, there is no meaning for the recursion. Sir, in this example, assume I want to print this message called hello. How many times? 5 times I want to print. Then you have to provide that 5 explicitly. We need to provide that 5 explicitly. Now I am giving 5. So it is a integer value, right? I am taking integer n. I want to print hello and I am going to call for n minus 1. So whenever the value of n is equal to 1 or whenever value of n is equal to 0 came, simply I will stop. Okay, the flow of control I will explain anyway, but please confirm. So what is this infinite recursion, finite recursion, and some theory part related to the base condition? Is it clear for everyone? Please confirm.
Yes.
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 Yeah, please confirm, guys, so that I will
Yes, Prakash.
explain
It
this.
is clear.
Sir,
Yeah,
one
good, sir.
doubt. The
Please.
program which failed because of Stack Overflow error, that also called as an infinite recursion.
Yes, exactly. Why? Because it is not stopped by our instructions. It is stopped because of memory issue. Can I say, is it runtime problem?
No.
It is runtime problem only. You can
Okay.
see, have you observed here? Exception, runtime, right?
Okay. Yes.
So we can't give, maybe my system is going to terminate at 10. Your system may take 100 steps. So no one can decide that. Got it?
Okay. Okay, sir.
Right. How to stop that one? Sir, please listen. Please focus. I'm going to give explanation. If you understand this, recursion is completed. Please focus. See, what is happening here is first JVM is going to call which method? JVM is going to call main method. So main method is internally calling another method which is taking the parameter as a 5. This is the first method call. Am I right? Please confirm, guys.
Yes, sir.
So this is the first method call. And there are few instructions are there here. What is the first instruction? Is number is equal to 0. Sir, as of now, this is n, right? Is it equal to 0? Please confirm.
No.
No. If it is not 0, it is doing two activities. What is the first activity? It is printing a message called hello on the output screen. Got it? What is the second one? We are calling the same method by passing n minus 1. So m of, what is the n value in this loop? 5, right? 5 minus 1 means what? 4. Like this, again it is redirecting to here. Clear?
Yes.
Now again this m of 4, what is happening? So it is a fresh method call. It will check is number is equal to 0. No. Then it will print hello message. Now, what is the latest value of n? 4, right? So it will call n minus 1, that is 3. So again, it is not equal to 0, right? So what will happen? It will print hello. And what will happen? It is calling m of 3 minus 1, which is nothing but 2. Sir, again it will print hello. And again it is calling for m of 1. Sir, again it is printing hello. So again it is calling for m of 0. Have you observed? Whenever m is equal to 0, whenever n is equal to 0, what we are doing? Return. Sir, anyone tell me what is the purpose of return keyword? To come out from the function. Am I right?
Yeah.
Yes, sir.
So it will come out from which function? Main function, and it will report to JVM saying my function execution got completed. That's all. Now, can I say this is the first line which is going to be printed? This is the second line which is going to be printed. This is the third line. Okay, so this is the fourth line, and this is the fifth line, and automatically the program is going to terminate here. Sir, can I say, is it finite recursion or not? Yes, it is nothing but finite recursion. Got it, friends? Please confirm.
Yes.
Yes, sir.
Yes.
Any questions? Now, if you want, I will run this code and I will show you. So what output we are going to get. Java C test.java, Java space test. So this is 1, 2, 3, 4, 5. So total we got 5 times. So this kind of recursion is called as what? Finite recursion, which is going to stop at a certain point. Sir, while writing the base condition, you have to put more concentration. Why? Because this is not the correct program, sir. Suppose by mistake, if I am giving -5, what will happen? Sir, first it will call for -5. Sir, is it equal to 0? No. So -5 -1, which will become -6, which will become -7. So -8. I think it is increasing in this side. It never reaches to 0, right? So it automatically, it is also will become infinite loop. How you can stop? So n value must be less than or equal to 0 means you can return either 0 or less than 0. Here -5 is less than 0. So it won't print one time also. So this program will work only for positive integers, the two greater than 0. So like that, while writing the base condition, we have to write appropriate base condition, which should terminate at a finite steps in this style. So if you are clear, then I will go for next scenarios. Clear, guys?
Yes.
Yes, sir.
Sir, everyone please respond clear up to this. Right. Good. So first case, what I covered is, if you observe, based on the number of method calls, how many types of recursions are there? Infinite recursion and then finite recursion. Now, second case, types of recursion, second case. So based on number of methods, not method calls, based on number of methods, we have two types of recursions are there. What is the first one is direct recursion and second one is indirect recursion. So I don't want to go any example, just I will explain at a top level. Sir, what is mean by direct recursion? If you have a method here, so if you call the same method again, then it is called as what? Direct recursion. So whatever examples we covered till now is a direct. Indirect recursion means what? I have a method m1 is there. So inside m1, we have two instructions, then I am calling m2. So in M2, what we are doing? In M2, it is having again two instructions. After that, it is calling M1. If you see, these two functions are playing games. M1 is calling M2. M2 is calling M1. Again, M1 is calling M2. So the method calls is keep on happening between these two. It will never stop. Again, if you want, you can put base conditions in both. That is different scenario. So how many methods you are using? If you are using only one method and if you are calling the same method again and again, it is called as direct recursion. If you are using two methods and one method is calling another method and that method is in turn calling this method, means it comes under indirect recursion. So based on number of methods, we have these two divisions. Any questions?
No.
Clear, everyone? Please confirm, guys, everyone.
I am
Yes.
good, sir.
Yeah, right. Next. So before moving to the another case, there is one more case is there. Before moving to that, just a small interesting fact about recursion. So need for recursion. Sir, when we can use this recursion and what kind of scenarios we are going to use recursion? Very simple. The first very important factor is, so if we want to reduce the length of code, then we can go for recursion. In yesterday, I covered one example like how to find out the subsets of the given string. For that, you can see how much big lengthy explanation I have given, but the code is almost 2 to 3 lines. But the code is almost 2 to 3 lines. Sir, how to do that? Very simple, right? By using this recursion, you can eliminate. Sir, next thing, if we have a common pattern, this one we have to identify. Is there any common pattern is there? We have to identify. From that common pattern, we have to remove some variables. Okay, from that common pattern, we have to remove some variables. So based on that, we have to analyze. This is nothing but what we have. So these two are nothing but the need for recursion. What kind of programming you can use means this is. Sir, best examples for recursion. Where we are using recursion? Sir, first example, divide and conquer. Divide and conquer. Sir, I have a big problem is there. For example, I want to perform addition of 100 numbers. Directly, you are not going to calculate 100 numbers addition. Even system also, it will calculate first two numbers. Whatever result you got, that will be added to the third number. Whatever result you got, that will be added to the fourth number. It is performing only addition on two numbers, but it is a small, slightly reducing the code. So it is a kind of divide and conquer. So divide and conquer means what? Instead of adding one by one, so you can take 50 numbers. So then these again you are going to divide into two parts. Then again you are going to divide two parts. So like that, we are keep on reducing. We are keep on reducing like this. We are keep on reducing like this. Then what will happen? At the bottom, we will try to solve. We will try to solve. Then we will give the result. And whatever result you got here, we will combine these two to submit to the result. So like that, it is a process of divide and conquer. If any big problem is there, you can solve this. Best example, sir, merge sort. Maybe next weekend I am going to cover these topics. Merge sort and a quick sort. Okay. Next binary search. So these things uses recursion internally, and even towers of an eye. It's a real-time problem, right? So how you are going to solve that? By using recursion only. Sir, Fibonacci sequence. Best approach is recursion only. Okay, subsets problem. I told yesterday, subsets problem. Okay, best example for that is nothing but subsets problem. Even tree data structure and a graph data structure, almost all the implementations. In tree, I'm going to explain minimum 25 operations. In that 25, I can say all 25 are implemented by using recursion only. So that much important. Okay. So these are nothing but some examples where we can apply this recursion. Sir, clear? Anything? If you have any questions, please let me know.
Yeah. So for merge sort, quick sort, binary search, we can implement using recursion. That is what you're saying, right?
Yes.
So we might have to write different functions based on the conditions
Yes.
and use recursion in those things.
Yes, yes. Sir, clear?
Yes. Thank you.
Right. So I will give some steps. Steps to implement recursion. Sir, if I am getting any problem, what steps I have to use to implement this recursion? What is the first step? We have to define base condition. First step is nothing but we have to write base condition. Means where we need to stop. So where we need to stop, that is a very, very important. Sir, where we have to stop based on base condition only, it will be decided, right? So base condition is mandatory. Then we have to define recursion call. This is also very, very important. We have to prepare recursive call so that it will be called for second time or third time or fourth time like that. And very, very important, inside base condition, we have to write a logic to terminate. Okay, to terminate and to continue. So to continue rest of the execution. So you have to prepare both the statements. Like in this example previously, we have not doing any job. So once if the base condition is satisfied, simply we are coming out. If base condition is not satisfied, we are printing hello. So these two jobs you have to implement properly in such a way that it should lead to termination. So anyway, I will explain that later. Once if you practice some examples, you will get clarity. And at last, what we have to do, sir, we have to combine the solutions. Sir, where we will get these solutions and all? From the stack trace, automatically you are going to get. These are the 4 steps that we have to follow, okay, while implementing the recursion algorithms. But don't worry, one by one, if I take some examples, you people are going to get much clarity. Any questions?
Sir, can you please explain difference between algorithm and data structures?
Sir, what is your question?
Difference between algorithm and data
See,
structure.
algorithm means a process. Suppose if I want to prepare any food, what steps I am going to follow? That is called as algorithm. Data structure means what? The technique which I am going to use. Suppose if I want to prepare some biryani, what I have to do? I need to get some items. Maybe 5 items are there. So I'm going to purchase these 5 items from the market one by one, and I will start preparing what steps I will follow. That is algorithm. Data structure means what? Sir, while implementing the algorithm, so maybe if I am going one by one purchasing, and if I am coming back to home, it is taking 5 minutes time. Sir, within 2 minutes also I can complete the shopping. Like what? Whenever I'm going, I will have a plan. Like these 2 items are available in a single shop. Let us buy there so that we can reduce the time. Like that, we are going to think, right? So that is called as a data structure. What technique we are using is called as a data structure, and the process is called as what? Algorithm. Both are very, very important. Clear, sir?
Yes, sir. Clear. Thanks, sir.
Yeah. And someone is asking, sir, can you please teach that technique? No, it is very from person to person, right? What are the standard techniques are there? Anyway, I'm going to explain. So, but the techniques are going to vary, depends on the logic, depending on how you are going to think, it will vary. But of course, 90% we have standard techniques are there. We will use those only. Okay, don't worry. Those things will be covered in that. Right. Sir, if you are clear, then I will take one more case is there. After that, we will go for programs. Sir, clear up to this?
Yes.
So this third case is very, very important, sir. This third case is very, very important. Please focus more. What is this third case? Okay, what is this third case? Sir, based on um based on based on place of recursive call. Based on place of the recursive call, we have 2 types of recursion. On what place you are calling? The first one is called as tail recursion. Second one is called as non-tail recursion. So in interviews, some people are going to ask, sir, what is mean by tail recursion? Sir, I don't know about tail and non-tail recursion, but I know what is mean by recursion. So most stupid answer is that one. Why? Because so how the function calls are going to be happen. So is very, very important to understand these 2 terms like tail and non-tail. So based on the place of recursive call, where you are calling, so that place will decide whether it is a tail recursion or non-tail recursion. But as of now, so I'm going to write one simple definition so you people will get clarity. So inside recursive method, so after recursion call, if we are not taking any instructions, then so such type of recursion is called as tail recursion. Sir, what is mean by tail recursion? Inside recursive method, after recursive call, if we are not taking any instruction. Sir, best example, I want to print the numbers, sir. I don't want to go, okay, let it be same program. So after, before calling this, so after this hello message, I want to print the value of n. This is my requirement. I am calling by passing 5. What is the output we are going to get? Already we have seen, right? Sir, in which order we will get output? You can see first 5, then 4, then 3, then 2, then 1. Sir, why in this order we are getting? If you observe our previous diagram, so there I mentioned very clearly how the flow is happening. Sir, are you seeing? The flow is nothing but what? First it is going to call for n is equal to 5. So that's why hello 5. Then for 4 it is calling hello 4. Then for 3 it is calling hello 3. Then for 2 it is calling, that's why 2. So then it is calling for 1. Then it is stopped. That's why we are getting hello 5, 4, 5, 3, 2, 1 like that. So this type of recursion, sir, this is recursive call, right? After this recursive call, so do we have any method calls? No, right? Or do you have any statements? After 8th line, directly the program is terminating. So this one is called as what? Tail recursion. Whatever I covered till now is the tail recursion only. What about non-tail? That is very, very important. Okay. Sir, clear up to this tail recursion? Please confirm.
Yes.
Yes.
Now, sir, non-tail recursion means what? Opposite for this. Inside recursive method, after recursion call, if we are taking any instruction, then such a type of recursion is called as what? Non-tail recursion. Sir, what is the example? After this method call, assume I am not printing hello here, so I am printing hello after this. Sir, can I say it is non-tail recursion? Sir, why it is non-tail? Because after recursion, we have some statements. Sir, is there any impact in the output? Huge impact will be there. Huge impact will be there. I will show you with the diagram. If you understand this diagram, there is one chapter called backtracking. The total principle of backtracking is going to work based on this one only. Now listen, I am drawing the diagram. So first assume the value of n which I am passing is 3. For your easy understanding purpose, I am taking a less number. At very beginning, what is the n value? 3, sir. Sir, first it will check. Is it less than 0? No. And it won't return. Sir, we are calling m of n minus 1. Parallelly, I will take stack. Sir, first we called main method. Assume main method is calling m by passing 3. I am not writing main entry here. Then what will happen? This m of 3 is calling m of 2. How I can represent in diagram? M of 3 is calling m of 2. Then is 2 is less than 0? No, sir. Again m of n minus 1. Then again it is doing what activity? So m of 2 minus 1, 1. So this m of 2 is calling another method by changing the parameter. Now m, one value, 1 is less than 0? No, sir. M of again n minus 1. Sir, 1 minus 1, which is nothing but 0. Okay. So it is calling m by passing the parameter as 0. Sir, can I say is n is 0? Yes. Simply it will come out. Simply it will come out. Sir, majority of students are going to feel the recursion is going to be stopped here. But here only the main problem is there. Okay, so here the recursion is stopped. But after stopping the recursion, because of this return, you people are going to think it will come out. Of course, it will come out. But after that in the stack, there are entries, right? So JVM, we have to report to JVM by clearing all these. So JVM will delete one by one instruction. Okay. Sir, up to this clear? Please confirm.
Yes.
Sir, if any questions, please ask here itself. Any doubts as of now? Anthony, clear?
Sir, just one doubt. After every 7th line for each of the instance, that 8th line also will get print, right, sir?
As of now, it is not printing because
Okay.
see, here we are coming because of this line. Again, from here we are going, right?
Okay.
Again, we
Okay,
are
sir.
coming. Again, we are going here. We are not coming to this line.
Okay, sir.
when this line is going to execute. That is the story here.
Okay, sir. Then fine.
Yeah. Sir, clear everyone? Abhishek, clear, right? Right.
Sir, for each iteration, actually, I mean, when the condition is getting satisfied, how exactly that return method, return statement will get executed actually?
No. When this return statement will get a chance, whenever n value is 0, it will stop, right? Return means what? Whenever you are in a function, we are coming out from that.
Yes. I got it.
So this is the story what is happening. But who is responsible to execute this line? In the stack frame, the entries are there, right? I told it is going to delete the instructions one by one. Now you will get proof for that. Clear?
Yes.
Prakash, I have one doubt.
Hmm.
You are saying that system.out.println will not be executed every time after m of n minus. That is not clear. I mean, immediately after m of n minus 1, we have a print statement, right?
No, but here you can see we are calling the method like this. We are coming, and it is a method call, right? From here again redirection is going to be happen.
Okay, got
it.
Yes.
Yeah. So now what will happen? My stack is going to play a major role. Sir, m of 0, whenever 0 is coming, return. So it will delete this. It will come here. Now m of 1, please confirm, is there any pending instructions in the method call when the parameter is 1? We have this instruction. Am I right, sir?
Yes, sir.
Now whenever m of 1 came, so that hello is going to print, what is the number you will get? 1, correct?
1.
Clear? In the output, can I say this is the first print statement which will get chance? In the diagram, it is last, but in the stack call, it is going to be printed first. Then m of 1 completed. It will come to m of 2. Sir, is there any pending instruction? Yes, this one again, it will execute. So at the time, what is the n value? The stack is maintaining, right? 2. Then it will print hello 2. In the diagram where it will come, so here it will come. Like in the reverse direction, it is moving. So then it will delete. It will come to m of 3. So what will happen? That hello 3 is going to be printed. So it will print hello 3. Sir, is there any pending instructions? No, it will report to JVM. My stack is ready to destroy. It will delete this data. So what is the output? In the case of, non-tail recursion, NTR, this is nothing but the output. In the case of tail recursion, what is output? So first hello 3, then hello 2, then hello 1. Sir, everyone understood this scenario? Please confirm.
Yes,
Sir, one doubt here. For example, here m of 5 is there. Okay, first initially it is checking 5 less than or equal to 0. Correct. Okay, 5 less than or equal to 0. The condition is
false.
false.
Then
okay.
what will happen? M of 5. Then what will happen? So it is calling again m method by passing n minus 1. Can I say m of 4 will be called?
Okay, m of 4 is there. Okay.
Again it will check. Again it is calling m of 3. Again it is calling m of 2. Again it is calling m of 1 until n value will become 0. Whenever n is equal to 0, it will stop. My question is, when this line is going to get a chance? Once if the all method calls completed, in the reverse direction, these methods are keep on executing if any pending instructions are there.
Okay.
Now, so the output, what we are going to get for this, you have to analyze. Sir, previous program output is there already. Now, what is the output of this program? Hello 1, hello 2, hello 3, hello 4, hello 5. In previous example, we got from 5, 4, 3 to something like that. So here we got 1, 2, 3, 4, 5, something like that. Sir, clear everyone? Please confirm. Any questions?
I'm good, sir.
Can you please show both the programs side by side so that we can compare and understand once again?
No, I think it is not possible, sir, in a single screen. Just this line is going to come first and this line is next. If you swap these two, it will become this one.
Okay.
Sir, clear everyone?
Yes. Yes, sir.
Right. Sir, to make it better understanding, okay, to make it better understanding, I will implement one small example related to the string and related to the array. I will take one example, sir, where you will get maybe much clarity. Okay. But please focus because you need to put more concentration. You need to put more concentration. Okay. So use your previous Java knowledge and whatever topic I covered till now, recursion. So both knowledge you have to apply and please see the code parallelly. Okay. Now I am starting a program, sir. So what is that example that I am going to cover is here I have a string. I have a string. Okay. So I will take the method name as something like method for easy understanding purpose. See, I am going to pass one string, sir. Let it be the string is Java. This is my string. So it is not going to return anything. It is having method input is nothing but a string. Yes, we have a string. Yes. So what is my requirement is I want to print the characters one by one. Okay. I want to print the characters one by one. In forward direction, we can print. In reverse direction also, we can print. As of now, I want to do it in forward direction. Forward direction, I want to print the characters. How to do that? Sir, very simple, sir. You have given method. When we have to stop this process, whenever all the strings got completed, we can stop. Am I right?
Yes.
So we have to pass the length. I don't know how many characters are there. That's why, sir, I'm going to find out length of the Java. Length of the Java. Better for your understanding, string s is equal to, I am taking Java and I am passing that string here. So how to find out the length? So s dot length I am taking -1 because I will treat this one as an index, sir. I will treat this one as an index. When we can stop? If the value of index is less than 0, I am going to return. Sir, why? Index values are always start from 0, right? That's why if any negative value is coming, I am stopping. Otherwise, what we are going to do? Sir, I am trying to print system.out.println of s dot char at of index. So whatever character present in that index, please print. After that, I'm going to call the same method by passing the same string. Index value, I'm reducing to -1. Now see parallelly what will happen. We are calling a method by passing the input as a Java and index value. Sir, what is the length of the Java? 4. 4 minus 1 means what? Sir, 3. I'm calling this first method, sir. Then what will happen? It will check is this index is less than 0. No, sir. Then what will happen? It will print the character present at third location 0, 1, 2, 3. Sir, third location character is A. In the output, first we will get A. Then I'm calling again the same method by passing the same string and index -1. What is the previous index? 3. 3 minus 1 means 2. Now what will happen? Is index is less than 0? No, sir. Then what we have to do? The character present at second location. Now we are calling a method by passing Java and index -1, 1. Now it will check is index is less than 0? No, sir. Print the character present at first location A. Then so call the same method by passing Java comma index -1. Is it less than 0? No, sir. Print the character present at 0th location A. Then call the method by passing Java comma index value will become -1. Sir, since it is negative, it will stop here. What is output, sir? Order is 1, 2, 3, 4. So let me execute this and check. Sir, is it printing in reverse order? Yes. So I can say it is in backward direction. This is nothing but the program. I hope it is making sense for everyone. Clear, guys?
Yes, sir.
My question, Tell me, is it a tail recursion or non-tail?
It's a non-tail regression.
Non-tail.
Recursion.
After the recursion method, there is no state or nothing. So it is non-tail, right?
Tail recursion.
Is
I think
tail
it's
recursion.
tail
Tail
actually.
recursion.
Yeah.
Why? Because after tail, nothing is there, right? So what is mean by non-tail? What is mean by
Sorry,
non-tail
tail
recursion?
recursion, correct. There
Non-tail
should
means
be
what? After recursion call, if we are taking anything, then it is non-tail. After recursion call, we are not taking anything. Got it?
yes.
Okay, sir.
Clear, everyone? Now, same example, sir. I want to print in forward direction. Forward direction. Sir, it is a very simple. What we have to do, you need to change the method call. Sir, this one I have to replace after this. So after recursion we have, right? Then it will become what? Non-tail recursion. Now see the code. I'm not changing anything. Only order I changed. Sir, if you see, we are calling a method by passing Java as the input and index value by default 3 because from the main method. Then it will check, is index is less than 0? No, sir. Sir, is it printing anything? No. It is directly going for method by passing Java and 3 minus 1, 2. So again, it is going method by passing. So Java 2 minus 1, 1. Again, it is going method by passing Java 1 minus 1, 0. Again, it is going method Java by passing 0 minus 1, minus 1. Whenever we are getting minus 1, it is stopping. But before stopping, it will check, sir, is there any instructions after this? Yes, we have, right? So it will come in the backward. So what is this process? When index is equal to 0, this line is going to execute. In index 0, which character is there? J. It will print. So the output is J. Again, it will come back. In index 1, what character is there? A. It will print. Again, it will come back. Sir, in index 2, which character is there? A. Sorry, V. So it will print that. Again, it will come back. Sir, for 3, which character is there? A. It will print. Like that, in reverse order, we will get. Actually, from here, we have to write J, A, V, A. Okay. So now let us execute and check same program, right? So like that, wherever forward and reverse direction movements you need, it is better to implement recursion. Smoothly the program is going to terminate. But don't go for any loops and all because there won't be any pattern, right? So if I use recursion, what will happen? Automatically it is coming. We are not required to think anything. Okay. But if the requirement is very small, then better to go for loop. If the requirement is very big, then you have to choose this recursion. Sir, I hope the second example related to tail and non-tail, it is very clear for you. Any questions?
I'm good, sir.
Time complexity and all you can please ignore as of now. See, time complexity is completely varying, sir. Time complexity is keep on varying. So if anyone is asking, sir, I want to eat biryani today. So is it recommended to book that biryani in Swiggy or Zomato is best, or preparing the biryani is best? Means I will suggest getting from the Swiggy and Zomato is very best. Same if 100 people are there. Getting the biryani from Swiggy or Zomato is best. No, preparing the biryani is best. Are you seeing? If the parameters are changing, the approach is also going to change. When we can use loops, if you have a limited resource, you can use loops. If you have unlimited resources or more lengthy code, lengthy data, if you have, better to go for recursion. So Krishna, I think my statements are making sense. Soon you will get clarity on that. That's what, sir. If you have two numbers, simply you can use A greater than B for comparing. If you have three numbers, you can take A greater than B. So A greater than C, then you can take a decision. If you have 100 numbers like A1, A2, A3, and so on, A100, are you going to use this approach? No. You will go for sorting. Got it? Someone is asking one interview question. Actually, I have seen this question few days back in one company. They asked this. Can we write a recursive algorithm for this example? Like input is nothing but like this we have. My output should be LE. So what is the meaning of this? What is happening? So it is removing the duplicates. Yes, happily you can do that. Nothing will happen. You can do that. Okay. But as of now, keep it in your mind. Later we will.
So I mean, using recursive algorithm, we can solve this.
Yes, we can solve. Anything is possible, sir.
Okay, thanks.
But you need to search for a proper pattern. If pattern is not there, we can't. If pattern is there, definitely we can do that. Okay.
Okay.
Right. Sir, I will take another two small or two or three small example programs. With that, I will conclude today. Okay. So what is another problem that I am taking here is, see, I want to implement, okay, I want to implement a small program for calculating sum of n natural numbers, sum of n natural numbers. So system dot out dot println of, so sum of n, I am giving 5. What is my expected output? 1 plus 2 plus 3 plus 4 plus 5 is equal to I think 9, 10, 11, 12, 13, 14, 15 is the output. Maybe you can start from 0 also, nothing will happen. We have to add these numbers. For that, I defined one method. What is that method? Sum of n, which is taking only one parameter, which is nothing but integer the number. So we have to return that. That is my requirement. First question, of course, we want to use this, but just to explain this recursion, I am using this technique. Because the problem is very simple, right? You can go with loops also. Sir, is there any pattern in this? Yes. If you add 0 plus 1, whatever result you are getting, you can give it to 2. Then those 2 will be added. Whatever result you are going to get, it will be added to 3. So whatever result you are going to get, it will be added to 4. Whatever result you are going to get, it will be added to 5. Better come from the last. If 0 came, we can stop. So what I will do is, sir, if the value of n is equal to 0, then I'm going to return. Sir, don't take like this because syntactically it is wrong, right? So because the return type of this method is integer, but you are not returning. When n is equal to 0, what is the value, sir? 0 only, right? Like that we have. Up to this, any questions?
No, sir.
Sir, one question. You mentioned loop versus recursion thing, right?
Yes.
So when to use loop if it is only
Very
small?
less data. Yes, for small set of data, we can use loops. When the data is very huge, you can go for recursion.
Okay. So for example, if it is sum of 100 numbers, if we use a for loop, you are saying problem is with the time or what?
So just for example sake, I'm taking, but even if
I'm,
you take,
I'm just telling. For example, if we use recursion for sum of 100 versus for loop, right?
Okay, sir, if you are talking specifically about this, as a beginning, I'm going to suggest if n is equal to 10, better to go for loop. If n is equal to 100, better to go for recursion. So if you have already some knowledge, then if n is equal to 100 also, I will recommend loop because there are some drawbacks in the recursion. So that's why I'm highlighting this recursion even if there is a negative point. Why? Because hero is recursion, right? That's why. So later I will explain what are the drawbacks. Okay.
Okay, sure.
You understood my point, right?
Yes, yes, yeah.
Yeah. In Pushpa 1, Allu Arjun is a villain actually because smuggling is very dangerous, right? But in first part, so he is a hero. In the second half, we are going to show what is happening in the second part. In the same way, recursion is not recommended. If you don't have any alternative method, then only we have to go. But what problems are there at very beginning, not required to discuss. We will see later. Okay.
Okay, sure.
Right. So, sir, up to this clear, right? Base condition wise, if you are clear, then I will go the main problem. I mean, main formula. Now, so what is the main formula? We are going to take a return n plus, again, I am calling the same function like sum of n by passing n minus 1. Now see what will happen. Sir, first step, we are calling some function by passing 5 as the input. Sir, it will check is 5 is equal to 0. No. Then what will happen? N plus is the main logic, sir. What is happening? N plus. N value is 5. So 5 plus, again it is calling sum of 5 minus 1, which is nothing but 4. For this 4, again 4 plus sum of 4 minus 1, 3. Again for this, 3 plus sum of 3 minus 1, 2. Again for 2, sir, 2 plus sum of 2 minus 1, 1. Again for 1, 1 plus sum of 1 minus 1, 0. Until getting 0, this one is going to keep on expanding. Sir, clear up to this? Please confirm.
Yes.
Clear, sir.
Now my question, when s is equal to 0, which value it will return, sir? 0, right?
0.
Now it will perform calculation. 0 plus 1. What is the result? 1. Who called this method call? For that function call, it will return 1. Correct?
Right.
So 1 plus 2. What is the result? 3. Who called this one? For them, it is going to return 3. Now 3 plus 2. Sorry, 3 plus 3. 6. Who called this method? For them, it is going to return 6 plus 4, 10. It is going to return. So 10 plus 5, 15. Who called this one? Main, right? For them, it is going to return 15. Got it?
Yes.
Sir, everyone clear this diagram and the code, sample code?
Yes, sir.
Yes, sir.
Can we say that internally backtracking is happening actually in this case?
Yes, backtracking is happening. We are giving the task to some function. That function is returning some value. By taking that, I am calculating again.
Yes.
Can
First we
you,
divided, right? First we divided into a small piece. If you observe what we are getting, first time these two are adding, right? Whatever result we are getting, that one we are adding to 2. Whatever result we are getting, that one we are adding to 3. Whatever result we are getting, that we are adding. Like that, can I say, is it a something like pattern is there, right? That pattern we applied here. Got it?
Yes.
Any other questions? Clear, guys?
Yes.
Right. Now, let me execute this and check whether 15 is coming or not. It's perfectly working. This is nothing but application what we have. So what is this application? Sum of n natural numbers. What is the next one that we have? Next example, maybe, sir, multiplication. Multiplication of n natural numbers. Sir, it is something like, can I say, it is factorial program. How it is factorial? Because we are calculating multiplication. Sir, can I take fact, something like that method name? And if I call fact of 5, what is output? You can't multiply from 0. So 1 into 2 into 3 into 4 into 5 is equal to 120. Now, so fact function is there. If n is equal to 0, we have to return 1. Why? Because 0 factorial is 1. And I am taking n into fact of n minus 1. So I think you can draw the diagram and you can analyze what is happening here. Sir, clear? Any questions? Sir, clear?
Yes.
I'm good, sir.
Right. Next, one more example. I want to do multiplication of two numbers using recursion. Of course, directly by using star operator, we can calculate, but I want to use a recursion to implement this multiplication. And what I'm doing is I'm taking integer MUL multiplication of two numbers, right? So I'm considering the first number as a X, second number as a Y. Later we will write the code. So I'm taking MUL by passing first number as a 2, second number as a 3. So what is my expected output? So 2 into 3, which is nothing but 6. 2 into 3, which is nothing but 6. Okay. Now, how to write the code? Multiple conditions I am going to take. Sir, first I will check, is the value of y is equal to 0? Is the value of y is equal to 0? Or is the value of x is equal to 0? Tell me if any one of the condition is satisfied, what we have to return?
0.
0. That is base condition. Among these two, if any one number is 0, without going in detail, we can stop there itself. This is called as base condition. Are you clear with the base condition?
Yes.
Now, otherwise, what I am doing? I am taking x plus, again I am calling multiplication function by passing x comma y minus 1. This is the logic. Sir, multiplication means it is something like addition only. For example, consider I am passing first 4 comma 2. I will change the argument 4 comma 2. So what is output? 4 into 2, which is nothing but 8. So 4 into 2 means what? We have to add 4 two times. That's all right. That's why x plus same function by changing the second parameter. So I will go the code diagram. Listen. See, first value is 4, second parameter is 2. What is happening? Is x and y any one is 0? No. Then what will happen? X plus, what is the x value? 4. Again we are calling the same function by passing 4 comma y minus 1 1. Now what will happen? 4 plus. So we are calling the same method by taking y minus 1 0. Sir, whenever it is returning 0, what it will return, sir? Because of this 0, it will return 0. 0 plus 4, it will return 4. Sir, 4 plus 4, it is going to return 8. Sir, 8 is our result, right? Everyone understood?
Yes.
Sir, clear? Any questions? Same thing, if you pass 2 comma 4, what is the result, sir? 8 only, right? Correct?
Yes, sir.
But what is a diagram? Sir, m of, so 2 comma 4. Then what will happen? 2 plus, so m of, sir, 2 comma 3. Again what will happen? Sir, m of 2 comma 2. Again what will happen? So m of 2 comma 1. Again what will happen? M of 2 comma 0. So 1 2 3 4 5 calls, only 1 2 3. Result is the same. You understood the point, right? Clear? Because in mathematics we have a rule, x into y is equal to y into x. Am I right?
Yes, sir.
So in this case, if you take 2 into 4, 2 into 4, these many calls are required. But if you take 4 into 2, less calls. That means a comma b, x comma y, if you are passing, if x is greater than y, then you will get less calls. If x is less than y, we will get more calls. Am I right?
Right.
Now, sir, which one is recommended? First one or second one?
First.
First one. So we have to reduce this one. Am I right?
Yes.
So what I am doing is I will put one more condition. Else if the value of x is very less when compared with y, please call the same function by taking y comma x. Just I am changing the parameters. Now what will happen? Sir, this is the first method call, m of 2 comma 4. Sir, it is going to check, is 2 is less than 4? Yes. Then m of, sir, 4 comma 2. Continuation from here. So we reduced the call rates, correct? Sir, clear everyone?
Yes, sir.
So this one, no one is going to write. Okay, if you think with your brain, you can able to write these kind of things. So some people are going to tell more complexity. Sir, if you write like this, less complexity. Sir, clear everyone? Please confirm. Any questions? You people are silent. Clear up to this?
Clear.
Yes.
I am good, sir.
Right. Right, sir. With this, I will conclude today's session. And in the recursion, I covered only some 40%. 40% of recursion we completed. So what I did in this recursion, I have given introduction to recursion. Next and after that, we have seen how method calls are happening and what is the importance of a stack. So how JVM is going to maintain this stack, what is the flow of control in this stack we have seen. So after that, we derived what is mean by a recursive method, then what is mean by a recursion, and even we have seen finite recursion means what. So infinite recursion means what, how to develop base condition we have seen, direct recursion means what, and indirect recursion means what we have seen. Next and after that, tail recursion and non-tail recursion we have seen, and what is the need for recursion. So how to write steps to write a recursion code, recursive algorithms we have seen. Okay, so and even we completed some applications. Like how many applications I covered, if you remembered. So multiplication of two numbers and the sum of n natural numbers. So then multiplication of a factorial of a given number. Then we have printed the string in forward direction and reverse direction. That's all. So these 5 examples I covered. We have around 30 applications are there. In that 5 applications I covered. These 5 applications are very basics, sir. Remaining we have 25 applications are there. I mean 25 programs. If I cover those 25 programs, recursion is going to be completed. In these 25 programs, so another 5 or 6 programs are very basic, low level, and remaining programs are moderate level. There are 4 programs which are high level. Okay, so those 4 programs are asked in lead code challenges also. Anyway, with explanation, next Saturday I am going to complete. Okay, next Saturday we are going to complete this recursion, and the session timings at sharp 7 p.m. we are going to start. So next week I am going to take up to 9:30 p.m. So next Saturday we will wind up this recursion. So clear, guys?
Yes, sir, clear. But one doubt is, I mean, there are more number of examples and complexity is more, right? So 5 weekends, is it possible to finish it?
Yes, sir, it is possible. Maybe if time is not permitting, maybe 1 weekend extends, nothing. Here we are not very strict to the timing, sir. But
Okay.
as early as possible, I will try to finish. Okay.
Yeah.
But I'm not going to skip any topic. Every topic we are going to cover. See, once at very beginning, it is hard, sir. Once if you are coming to my flow, it is very easy for me to bring.
Okay. Yeah.
Max time is required for linked list. Remaining things are simple only. Only for linked list, one complete weekend we are going to spend. Okay.
Okay.
So that time and space complexity has already been covered, I mean, in
No,
yesterday's session.
we are not covered, sir. Maybe even next weekend also, I'm going to give this introduction and time complexity, and these RAS string programs we will solve maybe on Sunday.
So including this weekend, it will be
No,
like a
not this
5
weekend.
week.
No, not this weekend. Next weekend upwards.
Okay, okay.
This is only demo, sir. Any questions?
So the timing will be always like 7 to 9:30 p.m. or?
Yes, 7 to 9:30 p.m. only.
Mhm.
So if everyone is required, then maybe one weekend I'm going to take 1 hour before that. I will inform you. Not every weekend. Whenever I'm talking about this binary search, ABL tree, okay, and linked list data structure, graph data structure. For these topics, I need some more continuity. More breaks are required. Okay, so that's why maybe I will start at 6 o'clock. Up to some 20% completed means I will give some 10 minutes break after that continuation, like that it will be there.
Okay, thank you.
And please available from 7 p.m. If anywhere I'm starting at 6 o'clock, I will give prior intimation 1 week before. So then you can arrange from 6. Please available till 10, sir. 7 o'clock to 10 o'clock. Please be available. If you want to learn data structure with full-fledged confident. So the people who are unable to attend, you can watch the recordings. My recommendation is live class is best. So at least for this linked list, binary search tree, AVL tree, and a heap graph for these topics, 1, 2, 3, 4, 5 topics. These 5 topics even for dynamic programming. Not dynamic. Yeah, dynamic programming. For these 5 topics, better to attend live classes. Remaining all are easy. If you watch the video, you can get. The people who are unable to attend live classes, for them I am giving this instruction. But recommended to attend live classes. Okay. Right, sir. Anyway, video access and running notes access you will get from tomorrow. The people who are interested, you can start making the payments. Okay. Yeah. Thank you, guys. If any questions, please let me know. Otherwise, I will wind up. Yeah. Then, right, sir. We will meet for the continuation in the next week with a new link at 7 p.m. Thank you.
Thank you.